three, test. Yeah. Okay. All right, looks good. Everyone know that? See it okay back there? I know there's a bit of glare on the screen. Okay. So this is for my first time lecturing for you, and so I'll introduce myself and kind of tell you a little bit about how that works for me. So I'm Karl Jensen. I've been mentoring here for a while. I've been instructing for a while as well, almost, I guess, 2 years almost now. It goes fast, but one thing that's consistent for me is that I like to get feedback on these lectures. So I say that up front and just offer that sort of, I'm inviting you to bring feedback to me because I like it. And it's not just feedback says that was good, but also more important would be the constructive stuff, the stuff that doesn't work for you in particular. Maybe a little too fast, too slow, not enough code, too much code. All those things are all relevant feedback that I may or may not incorporate into my next attempt at the same sort of lesson, right? Or future lessons, whatever it is. I'll be here today and tomorrow as well. I'm scheduled to lecture tomorrow, so you get, I guess we'll have 6 hours together this week. That's pretty exciting for me. And I haven't done tomorrow's lecture very recently, but I have done this Monday one. So I feel a little bit of pressure because I have to teach you about HTTP. And HTTP, as far as I'm concerned, is one of the most important topics that we will learn in a web development bootcamp, because it is the way that we communicate between clients and servers. So everything that we do tends to go over HTTP. Maybe not absolutely everything, but let's say in the 90s, like high 90s in terms of the percent of the work that we do has some component that is HTTP. Okay. And we're also throwing these acronyms at you, right? So HTTP, Hypertext Transfer Protocol. What's hypertext? It's that, well, what's HTML? HTML is the hypertext markup language. And so HTTP is the hypertext transfer protocol. So how do we think that these things might be related? Could we maybe transfer HTML over HTTP? That's kind of, I think, where the naming comes from. But the cool thing is that HTML is not the only thing we can transfer over HTTP. It's pretty much any text string. It just so happens that when we transfer HTML over HTTP and a browser receives it, we get to see the page, and that's what we like to see. That's how we interact with the web. So HTTP makes sense? And then API. So we're also starting to work with APIs, which are application programming interfaces. We can write APIs using the hypertext transfer protocol. So our API is really just a contract that we would provide to someone who wanted to write software against our service. Application programming interfaces exist not just like I will speak about them today, but also within all sorts of libraries that we'll use. It's just really a contract that we make with someone else to use that code, however it is. Okay. So these two acronyms, we're going to be using them quite a bit. So I want to make sure we all understand what both of them mean. Cool. All right, and the goal this week, or at least today, there's 2 projects this week. There's a very small project today, and then there's a larger project that starts tomorrow. And so project 1 today is called the GitHub Avatar Downloader. And the goal for us today, we want to use Node.js, which is our runtime environment, the place where we run our JavaScript at this point, to make HTTP requests to github.com. So GitHub has an API that we can use. And GitHub's API allows us to find out information about repositories and the people that contributed to those repositories. So one of the things we might want to do is make a request to GitHub and ask for information on that repository and then do something with that information. That's what GitHub Avatar Downloader is all about. You're going to make a request to GitHub. It's going to give you a list of all of the contributors to a repository. And then you'll be able to iterate, which we learned last week in JavaScript, through that list of all the contributors. And for each contributor, you will download a photo of that contributor and save it into your local machine. So this is the example for today. I won't be doing that stuff directly because you'll be doing that with the assignments, but I'm here to try and help you get to the point where you've seen that happen. Okay? that kind of thing happen. But I won't be talking about streams and stuff. I'll just be talking about how to do the requests with HTTP. Okay, so a protocol. This is an important term we're going to have to understand, and it is not the only protocol that we will use, and not actually the only protocol you have used. So all of you have used HTTP, whether or not you know it, right? When you load up a browser and you make a request to a site, type something in the URL, a request is being made to that server, and we get a response back. So a protocol, one of the more concise definitions that I could find or that I put together for you here is a set of rules. Okay, rules. That's the contract that we're talking about. We have to make sure that we both know the language that we're going to speak in. And those are we'll call those the rules that we use to communicate. So the rules governing the exchange of data between devices, those devices could be a phone and a server, could be two phones, could be a phone and a desktop or a laptop. It could be any two devices could communicate over that protocol, let's say. So has anyone heard of the KKJP? Right, kind of like the HTTP, the KKJP? No? Okay, cool. Cool, thank you. Thank you. So the knock-knock joke protocol. Does anybody know knock-knock jokes or not know what a knock-knock joke is? Okay, we all know what a knock-knock joke is. Good. So the knock-knock joke protocol, the one that we're familiar with, there is a set of rules that we have to follow in order to experience this joke, right? We have to have two people involved, sort of a knocker and a I don't know, a door answer or whatever it is. And so the first person will say the first thing that we're expected to say in a knock-knock joke, which is knock-knock. And when someone hears that, now they kind of understand the type of exchange we're about to do. We actually kind of understand what the goal is already. We hear knock-knock. So as the responder, we're going to say who's there. And that's we're told. We just say who's there. When we hear knock-knock, we say who's there. And then this is where it gets interesting, because that person who's telling the joke is going to come up with something that is hopefully unique and funny, right? Or will be funny eventually. So in this case, I'm not unique and funny. I used one that I found online. So knock, knock, who's there? The response is orange. So now, if we were to sort of try and describe what this protocol, what is the next response? What does the responder have to say next? Orange who in this case, but it's really just whatever. They have to take whatever was the word that was given to them, and then take that word and say that word plus who question mark, right? So we've sort of decided that we're going to take this input from the person who's asking the question, and we're going to use that to determine what our response will be. So it is a little dynamic in that way, that not all knock-knock jokes might have the exact same word said, right? So same with HTTP, we accept variables, and that could actually determine what our response is back to the server or the client, right? Orange, you going to let me in? This is the punchline. So we say, knock, knock, who's there? Orange, orange who? Orange, you going to let me in? Or lettuce who? Let us in, it's cold outside. That type of stuff, right? I'm not saying these are funny, but I think it's a pretty good analogy, right? That once we understand this language, we can tell these jokes as much as we want. And if we don't use the right, if we don't sort of use the right terminology, then we might break the joke, and someone will say, "Well, I don't know what to say next. I was going to say orange, but you didn't say who's there. You say what's up or something like that, right?" So there are other protocols that you've used in your lives, I'm sure. Anytime you've done like online gaming or anything like that, there's protocols in place there, all different layers of protocols. Here's some common ones on the web: FTP, so a way for us to transfer files. Large files. This used to be sort of the way we do that. I think there's better ways that I do this now, but the file transfer protocol has been popular for a long time. There's also one called POP3. It's the Post Office Protocol version 3. We used to use this for email. I don't know if people still use this for email. Nowadays, we use IMAP for email. The main difference between the two? Does anybody know? Okay. You're all familiar with IMAP because your messages stay on the server, and your device just syncs to those messages. And if you move to another device and you set up your email account there, all those messages get synced to your device. Whereas with POP3, when I downloaded an email from the server, it's no longer on the server, it's just on my device. So that's why we probably don't use POP3 anymore, is because it doesn't retain, and we have so much space on these servers now, there's no problem storing our 30 gigs of email or whatever it is that Google gives us for free. They're okay with that. IMAP is sort of a better protocol for receiving email as a result of that. It's a syncing protocol, right? So last one I'll talk about right now is SMTP, so the Simple Mail Transfer Protocol. This is actually the other side of an email, that when you create an email, you use SMTP to send it out to the recipient. Okay. Any questions about protocols? Do we understand sort of what we're talking about here with HTTP? Okay, so now I'm going to explain to you what that protocol actually looks like, the language that it uses, and sort of how we can use that to build our web applications. Okay, so here are two devices. A smartphone and a server is a good example of this. And when the client device, that's what we'll call the one on the left here, wants to get some information from a website, for example, you want to go to lighthouselabs.ca, then you would do a GET request to that server. And that GET request would look, the very first line of that GET request would be get/http/1.1. And there are three pieces that are important here. We've got the method, so get. That's the method we're using. There are many more. I'll talk to you about some of those. There's the second part, the path, so method, then path. The path is telling the server sort of what endpoint you're interested in. In this case, / just means the root endpoint. Chances are you're going to get that front page with all the marketing and all that. But if you click on the pricing button, you'd go to / prices or pricing or something like that, and that would be the path. So on that second request, when you click that link, get / pricing HTTP 1.1. That's the request line. Okay. Then you get your response back. That's how we actually get to the browser will show some information. Hopefully it's that front page. And so in the status line, that's actually the first line of a response. We're going to get back HTTP 1.1. If you haven't figured that out right now, that's just the version of HTTP we're using. We need to make sure we're both using the same version of that language. Eventually, we'll be moving to HTTP 2.0. For now, we don't really care about that. HTTP 1.1 is valid. So we get that version back saying, yep, I'm speaking the same language that you're speaking as 1.1. All right, and here is some information about that response. The first piece of information is called the status code, 200. What does that mean? Sorry? Success? Yeah. So that's a successful. That's successful. The response comes back with a 200 saying it's successful, and then also a little bit of response text. That's the third piece there. It's some text that also has like there's a message that goes with that 200, and that message is everything's okay. Some of the other popular ones you would have run into, 404, so 404, and then not found. So that would be the status code and the status and the message or the response text. That would be 404 not found, or maybe 301 moved permanently or something like that, right? A redirect. So lots of different possibilities for this. We're not going into depth on these status codes today. I will show you a few more. The key for this is there are things we want to remember today and that we need to remember today, and there are things that we don't need to remember because we can just look them up when we need them. And status codes are one of those things. If we know 200, that means everything's okay. We can start from that point and just start to build up our vocabulary. But we do it as we start to use more and more of these things. Okay. So we'll start with Act 1, which is the client, because in any sort of this type of communication, we've got two pieces. We'll have the client and the server. An HTTP request, which I previewed quickly. I'm going to call out the most important part of that HTTP request that we're learning today. So a request has three parts. The three parts of the request start with the request line. It's that first line that I showed you right here. Get / HTTP 1.1 happens to be the request line. The request line also has three parts, like I explained. The method, get, put, post, patch, anything like that. Delete. And the path, that's kind of determined by the person who creates the API, what that would say. But this is going to be that unique path. So these two things, we need to understand this because this is going to help us design API as we go through the week and then also how we use the API for GitHub today. So we want to understand what the method and the path are there for. The version I've not highlighted because it's not very important. If it says 1.1, you're in good shape. And then there are two other parts that are important for request. The headers and the body. So we start with the status line, method path version, and then we also have some headers. Headers contain metadata about a request, sort of when the request was made, so maybe the time the request was made, the type of content the request is asking for. That could be another thing. Maybe the length of the body that is being passed along. There's lots of things that we can put on the headers, and those are just key value pairs, similar to what we'd see in an object. Okay. And then the path. So we'll talk about the path as well quickly. Let's go through some of the methods that we can use, though. So I've written down two of the most popular methods. The one that we need to, the two that we need to use this week, but we are not teaching every single one right up front because there are many of them, and most of them we don't actually have to use. So let's make sure we nail get and post and understand the two real important differences between these. Okay. So I've put this term up there called safe, because one of the things we use to determine whether or not which method we're going to use is the safety of the operation. When I make a request to a server, does the behavior of that server change post-request, or after my request? Post-request is kind of a weird way to say it, because there is actually a post-request. But after the request has been made, would that server maybe act a little bit differently? And so I would consider that to be a change in state. Here's an example. I make a request to the server to get a list of blog posts. And then I make a request to the server to get a list of blog posts. And then I'm the only one on this website. Will that list of blog posts ever change? Not if no one else makes any other requests to this server, and I'm just doing GET requests to get those blog posts, then there's no intention for anything to change. Therefore, I should be using a GET request because it is a safe operation. Whereas, let's say that I go to a form, I type in a new blog post, and I hit submit. Well, now, if I get a list of blog posts, type in a blog post and submit it, and then get a list of blog posts, that's two different result sets back. The first one doesn't have my new post, and the second one has my new post. So then, in that case, that submission of the form to the server that's changing the behavior of the server, that's an unsafe operation. So I would not be able to use GET for that. I would use post instead. So that's the primary difference between these two methods. One is safe, meaning we can call it as many times as we want and not have a change of state to the server. And the other one is unsafe, meaning that when we call it, the state of the server will change, that they're modifying the state of the server in some way. Or at least that's our intention. Does that make sense? Okay. There's a second criteria here for us to choose these things. Typically, a GET request has no body. We're not really passing information to the server to add a new post or a new user or anything like that. So in that case, we're not adding body data to the GET request. But with a post, because we're trying to put post data to the server, it makes sense that we would put that data on the body of the request. And that body is down here, number 3. Okay. So get and post, we use one to retrieve information. We'll use one to modify or add information to a server. Okay. Should I go through that first or not? There's a few others. So you'll hear about put, you'll hear about delete. And if you are comfortable using those this week, that's a good thing. We should do that. And if you're not comfortable, that's totally okay as well. These add a little bit more specificity to the type of request we're doing. I could use post and put mostly interchangeably, most of the time. So they would be okay. Both are unsafe. So I'd want to use both of them, or one of those, if I'm trying to modify the server. And with a put request, I can also add body data. Now, I want us to go back in time a little bit and think about these not in today's world. Because today's world, we do a lot of work with, let's say, databases. So our post request might modify the state of a database. let's think about when HTTP was created and what it was created for, because that might give us some insight into why we use these terms get, post, put, and delete. So if you think about back when the web sort of was developed, you had all these scientists who wanted to exchange documentation, scientific documentation. So these things could be maybe files. And you might want to add some context to those files. So you might have some hypertext that has things that are bold and things that are headers, and just a way to just be able to format that content a little bit so it's easier to read. And so you have all these files, and what you would do is, I want to make this file available to people, so I'm going to put it on a web server that's connected to our network. So what I'm going to do is I'm going to post that file to the server. And what that would do is it would create a version of that file on the server, and then people can make GET requests to that same path that you just posted to, and they'd get that file that you just uploaded. Let's say that you wanted to change that file. If you tried to post that file, again, it should post essentially a duplicate of that. That's what post would do. But with put, the idea is that we actually replace that file with a new one. So we make modifications, we're taking the existing file that's there, we're putting over top of it. And that's like an update, right? So maybe we'd use put when we're trying to update some content. We already have a blog post, we want to edit it. Maybe in that case we use put to do an update. We'd still pass the data on the body. It's still not a safe operation. Does that make sense? Okay. And then there's delete. Obviously, I think that's a pretty good name for that. If we want to remove a file, or we'll also call these things resources. They used to be mostly just files, but nowadays we have this sort of general kind of catch-all term for the things that exist like that, which would be resources. And so if I wanted to delete a resource, I would use the delete method to do that. And I would provide the path to that resource with some sort of a unique identifier that would allow my server to know exactly which one of those resources I was trying to deal with. So if I wanted to delete a blog post, I might do a delete on /posts/12, if 12 was the ID of that post. And that would be my path. My path would give me, my delete method would tell the server what I'm trying to do, and my path would tell me what I'm trying to do that to. Is this okay? Yeah. Okay. So we got get, post, put, delete. They used to be used for sharing documents. Nowadays, we're doing a whole bunch of different things with this, and the web has, I think it's adapted pretty well to these changes. The technology is all right. I mean, we're only now going to like version 2.0 of HTTP, so it's been a long time. We've got this path here as well. There's just slight rules for this. If you've ever used Windows machines, you'll notice that your paths, they might start like with like a C:\\, and then you separate your directories with a \. The paths that we're talking about here for HTTP exist, the format for that exists pre-Windows. So they don't use Windows pathing, and that's, I mean, it's not a bad or a good thing. It's the reality. We use Linux pathing when we're talking about, or Unix pathing when we're doing this, and so does Mac OS. Ubuntu uses all this, so you'd be pretty familiar with this. But we want to be using // for our path when we're separating the different, I guess, parameters or pieces of information in there. Cool? Okay. And / is the root path. That's just what that means, and we'll use it that way. So here's our HTTP request. Got the method, the path, and our header. This is our first exposure to what the header might look like. We've got our request line, our request line at the top. The second part of a HTTP request is the header, the headers. And so these headers are key value pairs. The key that I'm using here is host. And that just sort of describes the host I'm making the request to. The value is example.com. So these are key value pairs separated by a colon and a space rather than, I don't know, a comma or something like that. Whatever it is. We've got lots of options for that. Cool? And host, headers. You can go header, 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 header. You can list as many of those as you want. And the way that we know we're done listing headers is we do 2 new lines, and then we start with the document body. So an HTTP request could look like this. get / HTTP 1.1. Then we start adding some. Now, the new line means this is where we start headers. So this is all just text, and there is some code that is parsing this text and it's going to split it up into the request line, the headers, and the body. So host example.com. What else do we want to put in here? Maybe the content length, 302. I'm just guessing. Let's say content or accepts. Text, HTML, or something like that. I don't know. There's 3 different headers that I've put on there. The first one, again, describing the host. The second, describing the length of the content on this, maybe. And then this request accepts HTML. You can put in JSON here. You can put in plain text. And you're not writing these. I'm just showing you what they look like. It's when we use things like the request library in Node that this text gets built for us based on the function calls we make. So I'm just showing you what this looks like when it actually gets sent across the network. It's just a piece of text. But this will get built by whatever library or tool you're using. And then here is some body. We might want to send back key 1 equals value 1 and key 2 equals value 2. So this could be, or I guess if it's a post request, we might have some body on it. And so the way that we know that we're starting the body and it's not just another header is we do it's 2 new lines, and then now you have the body data. Okay. And then when at the end of that content, that is the whole request. That's sent to the server, and the server will hopefully respond to that. Okay. So we'll talk a little bit about the server just because we need to know who we're working with. But again, tomorrow is where we spend more time with this. So response looks a little bit like this. HTTP 1.1, so we come back with that version. 200 OK, everything's good on that response. Or it could be 404 not found if we look up a path that doesn't exist. And then the same deal, headers and then body. And so if we wanted to see the, maybe this is our request that we make, and the response looks like this, HTTP 1.1, 200 OK. And then now we have some headers. And so one of the headers might be content type, and it's just sending us back some HTML. Content, this is actually probably where content length normally would go, because it has that body. I mean, we can go and example.com. If we bring up our inspector here, and we go into the network tab, we can actually see that when I make this request, we've made the request right here, and I get to look at all this information right in the browser. That the request URL, this kind of describes the whole request that's being made, including the host and the protocol and the path. The request method is is get. And we came back with the 200 OK. So the response headers, here's some examples of what some response headers might look like. The content encoding, gzip, it's telling us that this is coming back compressed. That's just a way for us to reduce the amount of bytes that need to be sent over the network. The browser would be able to unzip this, and then we'd have the HTML unzipped. Content length of 606, content type of text HTML with a character set. We've got the date that the request was made or response was made. I don't know. Anything that starts with X is usually a user-defined or server-defined. That's usually not like a standard type of response, because you can actually put any header you want on a request or response. It's just whether or not the other entity that pays attention to that or not cares about that. So this is how we kind of look this stuff up, is in the browser under the network tab here. And I drop down, I look at my request is made, and I can see what the response looks like. This is the body of the response right here. It is 51 lines of HTML. And we can see this is what the browser actually renders it as in the preview. But when we see the response, it's just plain text. might look something like that. Response line, all the headers, an extra new line, all the body. Cool? Okay. So here's some status codes. Again, like I said, don't try and remember all these. But these are some good ones to get started with. So 200 is okay. 301 means moved permanently. You'll be doing redirects this project. 400, bad request, means maybe you sent some data incorrectly. Maybe the wrong, it's looking for a piece of data that you didn't include, or you misspelt it or something like that. Maybe that's why a bad request. There's nothing super specific for this. 404 not found. That means that the resource that you're looking for, the path that you're making a request to, is not handled. So we send back a 404. And then 500 internal server error. You'll notice this happen if your database crashes, for example, or not crashes, but throws an error. You try and make a query to your database with malformed SQL. Your database comes back and says that's malformed, there's an error. And then your server might send back a 500 internal server error. We don't actually know what the error is if we're just the client, but we do know that the request was, everything was good with the request as far as we know, but the server had trouble actually completing that response. Cool? Okay, so definitely more on this tomorrow. Questions? No? Okay. So I've got an exercise for us to do today. Let me make sure I didn't miss anything. That seemed awfully, so knock knock, common protocols. Oh, I didn't talk about user agents, so it's probably good that I came back to this. How do we make these requests? What's one way? I already did it, right? So in our browser, we take we put a URL in the bar, we hit enter, I just made a request. I can also bring this up in size for everyone to see. And then curl, that's another way I could make a request, right? And so I've just made this request, and I got back a response. Happens to be the response that we saw in here, but curl doesn't know how to render HTML, so that's why we only get plain text there. And if we wanted to, we could actually see, if I do curl-v for verbose mode, this is curl making a request to the web server, or sorry, making a connection to the web server. So that's the first thing that happens. Actually make a TCP connection to the web server. Once that connection is made, we can now send our request as text, and it looks like this right here. So these little greater than symbol, that is, and less than symbols, those are just telling us which one is the request and which is the response. So I've highlighted the full request here. The request would not actually have those greater than symbols in it when it actually gets sent across. That's just something curl is using to show us. So what we're looking at here is that request line, 3 headers, and then a new line to indicate that the headers are done, but there is no body there. So that is the complete request. We can see the response comes back with that status line, and then a whole bunch of different headers here, and then a new line, and then after the new line, there's the body of our response, and this body of the response happens to be the HTML that is used for this page. And then at the end, the very last thing, well, it says connection host left intact, but basically we'll disconnect from that server, and if we want, we could connect again, make another request. Right? Okay. So that's curl. Lots of different options for this. So this is a user agent. On my behalf, the user agent is making the requests. Browser, curl, lots of other options. Take a quick peek at Postman. This one's kind of cool, Postman. I'll create an account another time. Yeah, right. But if you create an account, you can like save these things and then share them, and that's actually kind of useful in a team. Because what this allows you to do is create requests and collections of requests and stuff like that. And I can give it names. Basically what I'm doing is I'm saying I want to go to example.com here. I'm going to do a GET request to example.com. I send that. Here is my response. And I get to look at that as a preview if I want. It'll render it here. I can look at the raw text. I can look at it as a pretty text with some syntax highlighting. So this is a very good development client for HTTP. In a lot of ways, it's probably a bit better than your browser. Although your browser also gives you the rendered version, preview, the response. It's pretty. It's formatted pretty nicely. It's got some highlighting. So I would say either of these work well. But it's a lot harder to do post and delete and put requests in the browser, whereas in Postman, it's pretty easy to change this to a post. And I could make that as long as example.com accepts a post on the / path, then this would be okay. I don't know. Seems like it gives me back that no matter what. So that's how it handles that. Okay. So you've got HTTP IE, which is another tool. This is a little bit like kind of like Karl, except it actually gives us a little bit nicer feedback for this. So if you want to use a command line tool that's a little bit nicer, this one here, HTTP IE or HTTP, I don't know how they, HTTP, HTTP, yeah, HTTP. I can't say it. I don't know what's going on. HTTP. Yeah. Yeah, you guys can maybe make a game of it. I don't know. It's kind of HTTP. Did it. It's another one. Paw. That's a Mac OS one. You gotta pay for it. I'm just trying to show you here lots of different ways to make a request. We do not have to use only our browser, and we do not have to. Number one rule with HTTP: we do not have to have a web page that we have to make those requests. We can just make those requests with any HTTP client, debug it that way, completely make our server work the way we want, without having to build any HTML that does that. We could build HTML later on. Okay. I think people get caught up in this idea that we need to build the client and the server together, and the only way we test it is when they communicate together. That's not true. We can build the server independently by using a client, an HTTP client, to make the requests. We can build the client independently by baking the data on the client, and then eventually we can put those two things together. And that's usually a way to approach development. So yeah, keep these tools in mind. Anatomy of request, we did that. Here are the methods. Path, protocol version, content body. Okay, cool. So let's do a little bit. So what did we learn this weekend? What did we learn about this weekend in preparation for the week? Nothing? Yeah? About JSON? Cool, JSON. So I will be in my example today. We're actually going to be using some JSON data and then filtering out that data and making and displaying it in the kind of the way that we prefer. So I'm going to go to that the page that we'll use here. It's actually the location of this is API. What is API? Application Programming Interface. So we have an API to the Nobel Prize website. It's a pretty basic API in the sense that we just make a request to prize.json, and it gives us back a list of all the prizes and the winners. And it's really hard to read here, but again, we should always bring this inspector up, make our request, take a look at it, and then look in here in the preview. Because this is actually a JSON response, not an HTML response, the browser's giving me a bit of a nicer way to look at this, right? So let's get in the habit of that. And so the data that we want to work with, this JSON data we want to work with, is an array, or it starts off as an object. That object has one key in it called prizes, and that prizes is an array of objects. Each object represents a year and a category. So every year is going to have multiple categories. And then for each category and year combination, so in this case 2018 physics, we would see that the winners for this, there are actually 3 of them. So the winners, in this case, there are 3 winners. It's possible there is 1 winner, or 2 winners, or 3 winners, it looks like. And so what I want to do is actually make a request for this data over HTTP, and then filter out only the let's say the piece prizes, and then I get a list of all the piece prizes, and I can list out all the winners of the piece prizes for every year. That would maybe be something I'd do with this API. I don't have the data myself, so I use the API to get the data, and now that I have that data, I can write some software in JavaScript to do with that data what I want. Okay? What else did we learn? Sorry? Character encoding. Okay, a little bit of character. So what kind of character encoding did we? UTF-8. Yeah, so we'll continue to use that. You'll notice in my code, I actually set the encoding here for the response that's coming back. I'm going to say that that the response that comes back here, I'm expecting it to be in UTF-8 encoding. So we need to make sure that when we make this communication that we're not getting back characters that are not encoded this way, because we might not be able to read them. I think encoding is, it's an important part of that contract, the communication that we're making. Is there anything else that we learned this weekend? Yeah. Node streams. Cool, yeah, so I don't have to use that today. But you're going to be downloading an image, and you'll use node streams for that. You'll actually use a pipe function call to pipe the data that is being downloaded over HTTP into a file system stream. So down from a network stream, we receive that data piece by piece maybe, and it gets streamed into another, a receiver of a stream, which could be a file system input stream, and that could write files to the system. So this is how we're actually going to stream files off the internet over HTTP and then save them as files on the file system. Cool. Anything else? Okay. So we all know how to install libraries in Node, right? That's pretty, okay, good. So we're going to be using, this morning we'll be using the library called HTTP. I didn't have to install that one. We'll notice that when I look at this project here, there's actually not even a package.json. Because I'm not necessarily, I guess I could create one. But I'm not going to install any external packages for this. I'm only going to use packages that exist within Node, that one being HTTP. Eventually, we will use a request library, though. And that would be one I'd have to npm install request for. And then I'd be able to use that request library. That's something I could do this afternoon. And I will do this afternoon. But let's see how we would do this first with just sort of, I guess, vanilla Node or the Node library. And Node is, I'd say it has, it's not bad documentation. It's not incredible documentation, but I'd say it's above average. They keep it up to date. Sometimes it's a little bit hard to find what I'm looking for, but it's just, there's so much to it. So let's look at Node's website here. We're going to the docs, and we've got a couple of options over here. I'm noticing this v10.14.1 and this v11.3. And beside 10.14.1, it actually has this other acronym here, LTS. So these two represent versions of Node that I could download. And I can download any versions that existed before this as well. But these are the two latest versions. Why do I have two latest versions? Why shouldn't I just have one latest version? There's a stability concern there, right? So Node wants to continue to make changes to the software, but we want confidence that the software doesn't break as a result of that. So we're going to have two different Node's going to release two different versions. And the way they decide to do it is they'll have a version 6 and a version 7. And then they will have a version, I guess, 8 and 9, and then now 10 and 11. And one of them will be marked as the LTS. It's always going to be the earlier version. And LTS is going to stand for long-term support. Okay. So long-term support, once it's determined that this is now the long-term support version, and that version is going to change. It used to be version 8 that was LTS, and just recently 10 became the new LTS. So the agreement is that they will continue to improve the security of this version, but they will not add any new features to it. New features will only go in version 11. It's more risky that way. And security will also go into version 11. So version 11 will have the new features and all the security updates, whereas version 10, they've stopped putting new features into it, and they will only fix security issues as a result of that. Make sense? So I would target the LTS version, unless you're doing something cutting edge that requires the newest version of Node with that brand new feature that they just included. It's a good idea to run that LTS version. And then it's also a good idea when you choose to read documentation to click on the LTS, the version that you're using. So let's say that we're using version 10.14. Actually, we are not. So let's go find out what version we're using. Node-V. I'm using 8.11.2. What are you using? 9.4. Okay. I've got NVM here. I can list out. I've actually got multiple versions installed. I've got two versions installed. One's 8.9.4 and one's 8.11.2. You can do the same thing, NVM LS if you want. I'm not recommending that anyone upgrades Node right now. There's not really much reason to do that. You're on a good version. It's got all the features we need. But what you would want to do is actually look for the right version for what you're using. So 9 point something, right? We're going to go into the 9 documentation here. And this is where I would be looking up that documentation for my version of Node. It's important that we match the version of documentation, the version of Node. Why would we want to make sure we match those things? Yeah, and I start to make assumptions. Yeah, something changes between versions. And so now I'm trying to do something that works in my documentation but not in my code. So I've seen it happen a few times. And not only that, I've actually seen with NPM it can get kind of dangerous because people can choose the names of their packages, right? So I've actually worked with some people before where they'd come to me and say, I'm having this trouble. Like why is this not, this is not working? It's right here in the documentation. Or this thing's not working, can you help me out? So I go look up the documentation. It's like, oh, it's right here. And they say, where? And I send them a link. They say, what do you mean? That's not the documentation. Or, wait, that is the documentation. Oh, there are two libraries with the same name, and I installed one and I used the documentation from the other one. That's something that I've seen happen before. So we want to be very careful about that. When we're installing Node packages, you can call them whatever you want. So it's very possible that two names would be very close. So be careful of that. When it comes to versions like Node, we want to use the right version for that exact reason. That's kind of a general kind of tip here. Okay. So the library that we're going to install is the one called HTTP. Or we don't need to install it. All these things exist within Node. So we'll go to HTTP. And some of the things that I want to do with HTTP, I want to make a request with HTTP. So I'm starting to look through this, and at the bottom, I see request. I could also Command F, request, and start to find all the references to request here. Looks like there's actually some sort of a request object that I could call functions on. That's useful. There's also the stuff here. There's a request right here. So I can call http.request and give it some options. That options, those are described here. The options come in one of three data types. I can either pass an object. So why would I pass an object to as an option? multiple options, all encapsulated into one object. So I could pass this whole object, but give it multiple options if I wanted to. Whereas with a string, chances are that option is like the URL. So maybe it looks and says, oh, if you pass me a string, I'll just make a GET request to that. I'm going to just assume that that's what you want, because you didn't give me options that tell me what method to use. So I have to make some assumptions. So I mean, I would say you could use the object here, because you would also be able to put the host. You'd be able to put that in there as a string if you want to. You can put the port you're making the request to, the method that you're using, header information, so you can add headers to your request, all that sort of stuff. Okay, so we'll put some options on this, and in my example here, I'm actually using not HTTP request, but HTTP.get. So there's actually an even more shorthand way to do this if I want to do a GET request. It's right here, http.get. And http.get also takes options, except in this case, the method is always set to get. So I don't actually need to provide that as an option. And here I'm not using an object, I'm doing the string version, which happens to just be the URL that I want to make the request to. Okay. We will be passing objects as options when we make our requests for GitHub, because we're going to need to add some headers. It's going to be a requirement. GitHub requires that we add a user agent header, for example. We're going to have to add an API token. So the way we do authentication could be through a token that GitHub gives us to make sure that we are the ones making the request. We include that in every request. GitHub says, oh, it's you, good, here's your data back. So we put that on the request. We'll put that in the options. For now, I'm trying to make it simple. So our options are really just the string format, which represents the URL that I'm making the request to. And then I've got this here. What does this little square brackets around comma callback mean? Sorry? Optional, yes. So optional parameter of a callback. Now, as far as I'm concerned, that's not optional for me, because it's the only way I get my data back from the request, right? So they say I don't need to pass it. I could still make this request. As long as I don't care about what comes back, then the callback is optional. I don't think there's a situation where you're going to want to do that, so I think that you're always going to be passing a callback to this. So get, the first options, and then our second parameter is this function here. I'm just passing it anonymously, and if I zoom out, we'll see that this function exists from here all the way down to here, this part here. So this is my whole function. When I get the response back, call my callback for me, pass in the response, and I will use that response to figure out what the status code is. And if the status code is not 200, what does that mean? Sorry? If status is OK, then we will not do this condition. If the status is OK, we will skip this condition and we will continue down here. So this is the everything's good case. But if there is an issue, the status code is not 200, and that actually includes 404s and bad requests and everything that could possibly come back here, then we're just going to call the callback with an error. Okay? And that callback could check, it could receive that error down here, and if it has an error, then it would just log that error out to the console. Okay? If everything's good, then what we'll do is we'll grab the data from the response, and this is actually, I'm going to go into detail after the break on this. This would be us, we set the body, we set the encoding, and then we start to receive data in chunks. So in HTTP, we're not actually going to get the whole document in one response. It's going to come back in chunks of a response. So we're going to go through, we're going to download every single chunk, we're going to put it all back together, and we're going to call our callback now, not with an error. We'll say null for our error. There is no error. And then we'll pass the body, which is that all those chunks that we downloaded, back to the call back here. If there is no error, then what we want to do instead is we want to call getFilteredWinners, which filters the data based on the physics category, joins them back together with new lines, and prints out a big string of all the winners. That's what this does here. We start off the whole program by calling printPhysicsWinners. PrintPhysicsWinners makes the request, gets the response back, error or data, and then we handle that. Okay? When we come back from our break, take 10 minutes or so, and we will build this back up line by line. Okay? let's get back to this. So like I said, we kind of reviewed the program before we took our break. And now what we want to do is build this up from scratch, kind of understand what each line does, and go over, I don't know, anything you have questions about. So, oh, that's cold. All right. I want to save this here because I need to keep track of what my URL is. So I just put that up here. Oh. Come on. All right. So is anybody not clear on what the goals of this program is? Because if we're going to write this, we all need to make sure we know what the purpose of it is, or at least what it's meant to do. Anybody not clear? We're good. So we're going to take a list of prize winners, filter out the ones who won the Peace Prize, and then list out their names with the date. It's going to look a lot like this: node client.js. If I run this, this is what the output's going to look like. This might be for physics, I think. But we'll have the year and then a comma-separated list of the winners. We'll call them laureates, right? And then all the way back to 1901. Okay. So the first thing I need to do is retrieve my data from that server making the request. I'm going to use this shorthand get function from the HTTP library to do that. And I'm going to put the URL in here. And I could run this now, and it would actually make that request for me. I just don't know what the response is because I haven't provided the callback function. So that's why I said that I don't believe that this is actually optional, because for me to have any use from this, I kind of want to see what the response is. I guess there are use cases where you just want to fire and forget, but I think those are pretty minimal. So let's just assume that for the most part, a function is going to be passed here to the get. And I need to now kind of go back to my documentation and see, well, like, what is this? What is the structure of this callback function? What sort of data is provided to it, and what are the names of the variables that are provided to it? So I'm going to kind of take a look through this documentation and see, like, is there, okay, it comes back with a single argument here. And that single argument is an instance of something called an HTTP incoming message. So I'm going to assume that there's something called an outgoing message. Maybe that's the response. But for now, this is going to be, or sorry, this is the incoming message. So this is coming back to me. So this is actually the response. This is what I want to be using down here. And it looks like in my function, I know this is a little bit different syntax than what you were used to so far. This is an arrow function. We'll talk about those tomorrow afternoon in more detail when we talk about ES6. But for now, I'm going to just tell you, this is a function that takes in a single parameter called res. And I think they mean response. So I'm just going to put response in here, because then no one's guessing what I mean by res. What other things could res mean? Yeah, residential. What else? Lots of them. Sorry? Resolution. Resistance. This is better than I've ever. Those are three that actually no one said before. So, but some that are really relevant to the type of stuff we do. Result, that could get really confusing. A response or a result, right? Those both could be res. Resource. We talked about resources a little bit, so that maybe callback comes back with a resource. Res could be that. So I like to put, at least when I'm teaching you, I like to put the full word in there and write down what I mean. Okay, so you'll see me put request response, not rec res. Although in a lot of the documentation, a lot of the assignment stuff, you're going to notice that shorthand is commonly used. I can type fast. I've been able to type fast since grade 9. Thanks, Mr. Zloman. All right. So I'm going to get this response. I just want to see what this looks like. And the way that I'll do this, I'm going to run this application. Normally, we're running our application here, right? So I run that, and I get back my console log. I'm going to start running my application right inside my IDE here, because I find that it's a little bit easier for me to, I like to use the debugger, and it's also easier for me to explain to you what's going on in the application if we do that. So quick side note, Visual Studio Code has a built-in debugger. It means that I can do things like set breakpoints. So that little red dot that I just put down there in my code, I want the code to stop executing on that line before it executes that line. And so before http.get is called, it's going to stop my program from executing. I'm going to run this. I can click this little play button over here. I can click debug, start debugging. And it looks like I can also hit F5. So I hit F5. It runs my program, and it stops at that breakpoint. So here I am now. Excuse me. I have two variables, HTTP and URL. And I'm actually able to see what the current values of these are by just kind of rolling over them, right? That at this point when this code is called, URL is equal to, cool. And that means that I'm going to actually call this function HTTP get with that URL. And then when that response comes back, it's going to call this callback function here. So I want to actually set another breakpoint inside here, and I can continue execution, and it will stop at my next breakpoint. There we are. I just got the response back from the server. And I can take a little peek at what that response looks like. It's a little bit easier when it's zoomed in like this to look along the side here. My response, which, as promised, is a incoming message, has a whole bunch of data on it. I'm going to ignore the underscore stuff. That stuff is usually private. It means that we should have no business changing or using that stuff. Because there is really no privacy in JavaScript. So people might use a convention on their variable names to indicate that they intended that to be private. So I'm not going to use any of those. But there is stuff like oh, here's a list of headers. So these are the headers that came back on the response. And I can grab those headers as I can find the content type. I could X powered by. Remember I said X is determined by the server. You can put anything you want if you have an X before it. Well, this says that this server is running PHP 5.3.3. That's a little bit of information about that. We've got HTTP version 1.1. We've got the status code and the status message. So I can actually print out status code. And actually, my editor is being really nice to me. It's telling me that that is something that exists. So I'm going to run this again. And I'm not going to run the breakpoints this time. I'm just going to run the app. And we're going to see the output now. As long as I open the debug output. No, the terminal. That's what it is. And it's not the terminal, of course. It's the debug console. It's not output. It's not, OK, there we go. So the debug console is going to be kind of similar to what I have here. And when I run it, I'm going to get the output for my program down here. What is this telling me? Status is OK. Yeah. So my status code has come back as 200. So this is a good way for us to figure out whether or not this was a good request or not. It's a good response. Come back and we say we only want to do that filtering. We only want to find those winners if we get a 200 back. And so that's where we're going to say if the response status code is not equal to 200, then I want to return from this program and didn't get here. Some error. And we said that there's a status code as well as a status message. So we'll use the status message here. OK. If I run this normally, we did get there because there was no error, right? But as soon as I cause an error, and here's a good error, like make a request to something that doesn't exist. So I run that now. And it's coming back with bad request. I would expect 404. That's the peaceprize.org people That's the Nobel Prize org people to deal with that, I guess. But this is what the, it came back as a 400. And my status message is bad request. Okay. So this piece of code works. What I'd actually want to do, though, is, well, actually, for now, this error printing out is OK. We'll do this for now, and then we'll come back to it after and refactor this. I think it's actually good to write this simple and then refactor it after. So I should get here now, because my request should always be good. And so if I get here, what is it that I want to do with the data that I got back? With this response that I have. I know that's a good response. The response doesn't include the body. I still have to download the body. Think about it. The body could be, the body of an HTTP request could be a 3 GB Linux install. Why not? How many chunks would that be? Thousands, probably, right? Because we only get a little bit of data at a time. We don't wait for this whole thing to download before our app is responsive again. So we need to hook in to this event system that the response has. The response has this idea that it will download the data for you. And it has this idea that it does not, well, and we don't know how much data it's going to download. So there are two events that are important to us. The first event that we care about is the one that says, I have data for you. And the second one we care about is the one that says, I don't have any more data for you. Does that make sense? So the one that says, I have data for you can get called many, many, many times. That's the chunk behavior that we may have looked into. But the end one, the one that says, I've got no more data for you, that's just saying, take all the chunks that I gave you, and now that is your data. Okay? So I have two events that I want to hook into. Response.on is going to let me do that. I'm going to be able to hook into a response event, one called data, with this call right here. And there are two parameters that I give it. I give it the name of the event that I'm interested in, and I give it the function that I want it to call when it wants to trigger that event, when that event is triggered. So when the response says, I've got new data for you downloaded, it'll pass that data into this function, and we can just console log it. Let's see what happens. We run this, and I just got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of output, it looks like. And so I would assume at that point that my response.onData call got called 11 times. What happens if I switch this up here to example.com and I run this? Oh, hold on. That's weird. I expect to get just one chunk because it's a pretty straightforward site. Let's try that one more time. There's something printed out here. That's interesting. Try that again, and otherwise I'll move on from that. So yeah, that's weird. I'm going to look into that after, because I expected that to just make the request. Is this still working? Yeah, okay. I'm getting all that. What I want to do here, I'm going to set the encoder. We talked about UTF-8. So I'm going to set the encoding to UTF-8 and tell the response system that when it sends me these chunks, they should be encoded in a UTF-8 format. And let's see if this changes our chunks at all. And it does. So, oops. This thing is not going right. So here are the chunks of data. Oh, wow. Yeah. So now we can notice that it's no longer these buffer things. It's actually plain text that we're seeing. And so that's a good reason to set the encoding on this. What I want to do is actually, as I receive these chunks, I want to keep track of them. And so we're going to use a JavaScript feature called closures. We've heard of that. Everyone's heard of closures, right? Anybody not? So if I have a closure, what I would do here is I'd say I have this variable called body. And so by creating this inside the scope of this callback function here, the body variable is accessible inside of this function here, for example. Okay. So I can take the body, and I can add to the body whatever this chunk of data that just got downloaded is. Right? But we have a bit of a problem because if I console log the body down here, we're going to need an empty string. Is that clear? Does anybody not know why we would get an empty string here? You don't know? You're not sure why? Right, so I'm going to set the variable body, right? And then I'm going to set the encoding, and then I'm going to set up an event handler, but I have not received any chunks yet. It's asynchronous, right? So because of the asynchronous operation, this code, this code, this code, and this code will all execute, and then most likely sometime later on, this will get executed. So that means that the body won't actually have any modification done to it by this point in time. If I run this, it prints out empty string. And the way that we solve this is we need to make sure we know when there are no more chunks left. And then when there are no more chunks, then we print out the body, because that's all of our content. So here we say response.onEnd, so we know when there are no more chunks. And on this, now we print out the body, and we wouldn't get an empty body anymore, of course, unless our response comes back at empty text. Now it'll execute this, create our body variable, set the encoding for us, set up the event handler for data, set up the event handler for end. And then we're going to get the data event called many times. And then when that's all done, we're going to get the end event called. And at that point, because of this closure that's available to both these functions, they share that variable. Body will equal the entire output. Oops. After argument list, down here. So this error, syntax error, missing a closing bracket after the argument list, I just forgot it down here. Got to close that, so I have the matching one here, and I run this. And I get back all of the text here. Let's do that this way. So I scroll up. Just lots of content. All the way to the bottom is, looks like it's the end of my date. Yeah, year 1901. So it looks like I got all that data. Make sense? Is that okay? Yeah. This part is it's interesting because when you move to use the request library, you're not worried about chunks anymore. Request is built on top of HTTP. And so request library does the chunking and just gives you when it calls your callback for you, it gives you the already chunked body data. And you just use that body data the way that it is. So I'm just showing you how that does it behind the scenes, but eventually you won't have to do this on every single app that you build. You won't have to do that for every single request that you make. You'll use the request library instead. And the request library comes back with an error, a response, and a body, rather than just a response. That includes the error and the body that needs to be downloaded, right? All right, so where are we now? So we're printing out the body. Now this is what we were actually after, right? This body is what we were really curious about. So what do we want to do when we take this body data, that array of objects? Or I guess it's an object with an array of objects in it. Right, so we're going to filter that data. And so we'll use the term filter. So we're going to filter out of all this data here, which ultimately is a little bit easier to read here in my debugger, right, or my Chrome Dev Tools. So this is the data that we're getting. I want to filter out only objects here that have a category of piece, for example. Right? So I could start to write that code in here, but that's going to be maybe a lot of logic. So maybe what I want to do instead is say I've got this function here, and we can give it some, I don't know, like filter prizes or something like that, and we give it the list of prizes, and it returns a filtered list, maybe. Something like that. Or yeah, let's return a filtered version of this list. Right? So then what we would do is we'd console log the filter prizes. And now what I have to pass in here is actually it's an array. It's not a piece of text. It's not a string. And what we got back from the server is actually JSON. So it's a string. We need to convert that string into an array of objects, or an array and objects. Is that clear? Parsing. So we're going to take this prizes is going to be equal to JSON.parse the body. Okay, so JSON parse is the function we use to take a string of JSON and convert it to JavaScript objects and arrays and whatever that JSON describes. Whereas JSON stringify goes the other way. We can take an object or array or an array of objects and convert it to a string of JSON that we can transfer over HTTP. So we have these two methods, typically referred to as serialization and deserialization methods. Yeah, so JSON stringify, JSON parse are the serialization methods we'll use. So what is prizes going to equal at this point? I'm going to run this with the breakpoint there and just kind of see what prizes is equal to at this point. So prizes is an object. You can see that. Prizes is an object. The parse function returned an object, and that object has a key in it called prizes, right here. And the prizes key contains an array of 589 prizes, it looks like. So what I really want is not the JSON parse body, but JSON parse body grab the prizes from that. Does this, what I just did, does that make sense? Maybe not? Is it clear? I don't know. It's the kind of the same as saying like var data, or let's say parsed equals. And what type of data structure is parsed? Object, right? So our prizes are actually under parsed as a prizes key. I can do shorthand though, because JavaScript will just let me chain these things together. And because JSON parse returns an object, I can grab that prizes key from the object and you just use that directly. So that's what I've done there. So now prizes isn't going to be an object anymore. Well, I guess technically it is, but it's a special kind of object. What is it going to be? It's a special kind of object. It's an array, an object that that has a length and also is keyed by indexes. So here, array of 590 items. Prizes is now the array of objects that we were looking for. Cool? And I could take prizes here. I could console, or I could maybe like for var I equals 0, I is less than prizes length, I plus plus, and we just kind of console log each prize. So now this is what we're getting back on every iteration. We're getting back an object. Okay, cool. So I'm going to take those prizes. I'm going to filter. I'm going to create actually a filtered version with filter prizes and past prizes into that. Okay. So right now, this is just going to print out everything because our filtered list doesn't actually actually, it's going to print out an empty array because our filtered list doesn't do anything. So let's implement this function here. I need to go through every item in my list, right? Okay. Does this code allow me to go through every item in my list? Yeah? Okay. So I'm going to go through every item in my list, and when I match a certain condition, then I want to include that in my filtered list, right? So what's the condition I need to match? Looking for piece prizes. And so what's the structure of our object? Every one of these objects is going to have a year and a category and laureates and overall motivation. What we care about right now is that category key, because that's what we're going to filter based on. When the prizes category is piece, include it in the filter. When it's not, leave it out of the filter. If list I, that's the object, dot category is equal to piece, then take filtered and push onto it the list at index I. And then at the end, we'll return that filtered array, right? And so now what this should print out is actually the filtered list with only piece prizes. Piece, 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 right? So we've successfully accomplished that. Okay. So now I have these filtered prizes. What was the next step? So my output was actually just going to be the year, 2018, and then a list of comma-separated names: Arthur, Ashkin, Gerard, Moreau, Donna, Strickland. So what we'll end up with is 2018, and then these names with comma separation. So I need to grab the year. That's important. And I need to then go through all the laureates. And for the number of laureates that I have, I need to take their first name, their last name, put those together, and then combine all those values with a comma. Does this sound familiar at all to stuff we've done already? Like we've done this, right? We've taken a list of things and then converted it into a comma-separated list. So let's do that. We will have to do this for every single filtered, everything in the filtered list, right? So let's say for var I equals I is less than filter.length. So I'm iterating through every item in my filtered list. And for each item, what I want to do is I want to grab maybe a list of names, or maybe I'll just say var names is equal to empty. And then what I'm going to do is I have to do another loop inside here, right? Because I'm looping through every prize, and then when I go and look at one prize, I need to loop through all the winners of that prize. So I'm going to go and say for var j equals 0. I'm using j because it's the next after I, right? J is less than, let's say, filtered dot, or filtered I. We're looking at this. Maybe this is the prize we're currently looking at. We'll just keep that reference so we can use that over and over and over again. So prize dot laureates. I don't know how to spell laureates ever, but something like that. Laureates, maybe. Does that look right? Okay. Feels right. I don't know. This is my data. So whatever this says is definitely right. I just copied the key out of my data. When I do that, I'm sure that I'm right about what I was looking for, right? Even if it's misspelt, at least it's what I'm looking for. So here's prize laureates, and I go through each of these. And so for each of these, I'm going to take those names and I'm going to push onto it some data. that data is going to be the first name and the surname with a space between them. So I will take this prize laureates. Maybe I'll go down here and say there's a var winner is equal to prize laureates at j. And then I want to take the winner.first name, I think, first. Oh, no underscore there, so first name. And I want to add a space in between, and then I'm going to do winner.last name, surname, thank you. Winner.surname. And so once I've gone through all these laureates, what I should end up with is my names array should have it should have a list of all the people that won it. So I'll actually put names down here. Sorry, names. So I'm going to log that out now, and I'm just going to see what this says. Oh, that. Thank you. Sure name. Yeah, it still didn't work. So here we want to take prize laureate dot length, right? Grabbing the laureates, that's an array, so I need the length of that thing. And then for each of these prizes, I now have a list of the winners. How can I make that a comma-separated list really easily? Here's a hint. You were asked maybe not to use it for some exercises last week. Dot join, yeah. Concat would take arrays and put them together. So we'd actually have, maybe if we had two arrays, we wanted to put them together, we'd use concat. And that would actually make one array with all the values in it. But what we want to do is actually join with a string. And so we can call names.join here and give it a pipe. That would join it by the pipe. We see we have a pipe between each of the names. We could join it based on comma space. So when we run it like this, we actually get the name and then comma space, the next name and comma space. So we can, here's a winner, Betty Williams, comma space, married Corrigan. Wow, wow, good name. So we're getting pretty close here. We've got this names list. What we want to really do, though, is console log the year. So prize.year plus, put a space there, and then put our names. Log that whole thing out. And I believe we have, oops, of course, missing in the, forgot the plus somewhere, right here. Try that again. And here we go. We've got the output that we were looking for. These are only winners of the Peace Prize. We can see that Barack is in there. We've got, well, yeah. I think Malala's in there somewhere too. So we've got all these winners here. This code does what we want it to do, right? You're going to notice it doesn't look anything like the code that I've submitted to the notes. It looks very different. So let's spend a few minutes refactoring this, because I want to show you some function we can use in JavaScript to try and make this a little bit nicer. This is a filter. And we do filtering a lot in JavaScript. We take a list and we try and remove items from that list, and we want a new list out of that. So I'm going to actually rewrite this filter a little bit different. Instead of creating an array, looping through my other array, and then pushing onto it every time, what I can do is say, I'm going to take this list and I'm going to call filter on it. And list is an array, so I can call filter on it. I can't call filter on things that are not arrays by default. So list.filter gets called on the array. And this takes in a function. And what this passes is actually the current element that we're looking at. So filter takes in a function. We'll call it a predicate function. Looks a lot like a callback. But the intention is actually that this function is run on every single item in that list. And when this function returns true, we include it in the resulting filter. When it returns false, we do not include it in the result. So here I could say, return true. This list that I'm going through, this list maybe has well, I guess it's 500 and something items in it. If this was the case, my return will have 570 items in it because I did not filter anything out. I just returned true for everything. If I put false here, then every single iteration, the function returns false. Therefore, none of the items get included in the filter, so we get an empty array back. So then there's the in-between. What is the condition that I use to filter? Yeah. So here, the current element, that is list I, right? So the current element, if the current element dot category is equal to piece, when it's true. And when it's not equal to piece, this is false. So now we get a filtered subset of those results. And this is a lot easier to write for me. I don't have any off by one errors. I'm not having to think about indexing into an array. All I'm doing is saying, call this function on every array. This function, you provide to me that element. I get to tell you what the logic is to determine whether or not this is included in the filter or not, just like I did up here anyways. So I want people to start to get comfortable using the filter function. Sound good? Okay. So if we can filter things that way, we could also do a map. So a map is actually a way for us to convert an array of elements of one type into an array of elements of another type. Or, I mean, you can convert them into anything you want. Basically, here our types are an array of objects, each one representing a laureate, and we want to convert that to an array of names, comma separated. But those are two different data types. One's an object and one's a string, right? So here what we would do is we would say that our names is actually the prize.laureates.map. Okay, I'm going to map over this array of laureates. And I'm going to get back an equivalently sized array of names. Cool? So here, what this map takes a very similar, it's very similar to filter in that it takes this, this type of like predicate function here. So our map is going to take in a current element as well, actually a function takes in a current element as well. And so what we want to do here is whatever we return from this is going to be what is at that index of that array. So always the same. If I wrote a map function that in that predicate always returned the same value, then my names here what's going on here? There we go. Debug output, good. So that just tells me that it's running. Okay. So here, when I take a look at what the value of names is right now, it's actually an array of 2 items, and it says always the same here, because I returned always the same. So this started off as an array of 2 objects that each represented a prize winner, and I converted it to an array of text that says always the same. But what I really want is to take that current element, and I want to take their first name, and I want to add it to the string with the surname. So now when I run this, instead of it being an array of, I guess, the same value over and over and over again, I look at names, and I get those actual names there. Okay. So I've converted from an object to an array of objects to an array of strings. And then the last thing that I want to do is take that array and join them there. Well, I guess we should kill this code first, because I've just replaced that with my map. And so now I'll join those names still. I could technically pop that on the end there and just put names in here instead. So this would actually give us the same result. Still, year, comma separated names. And because map returns an array, I can just chain the join right onto it. I don't have to store it as a variable and then call join on it. So this is valid as well. Okay. Any questions about this? No? It's not exactly what we started with, but I get into I'm in the habit of actually not providing the exact code that we wrote. What I like to do is show you the code that I wrote, bring it back down to blank, build it up. It might not be the exact same, but it would be written in sort of, you saw how I did the initial and then the refactor. This client JS here has, it's broken up into more functions and stuff. We're also noticing here I'm using, the filter. I'm using the map here. We're still doing the join built into it. So it's not very different, but this is sort of the example that you have. Excuse me, if you're curious about what I went through exactly today, take a look at the video. I posted the link in the channel, so you can review that pretty quickly. Any questions before I'm done here? Yeah. Oh, good question. So the question is, why did I call that certain type of callback a predicate? So callbacks are generally used for asynchronous operations, right? Like I want to make a request, and then when the response comes back, call my callback for me. Whereas a predicate is more about calling the same function. It's more about the way I look. It's like you want to define what behavior happens on each element, and so you're providing a function that defines that behavior. This code is running synchronously, though. When it goes through this filter here, this is not asynchronous code. And that's why I don't call it a callback, because I tend to use callbacks for asynchronous code. I call this a predicate because it's a function that's passed in to a synchronous function. And this function is just going to call this on my list, on every item in my list, and I get to still determine what the behavior is for every item of that list. Does that kind of make sense? So that's why I call it predicate, because it's not the same as a callback to me. That this that this does not get called randomly sometime in the future. It gets called immediately n number of times based on the length of my prizes array. I hope that answers it. Anything else? Okay, so when we come back this afternoon, I've already sent the notes out, so if you do get a little bit ahead, you can review those. Come back this afternoon, we'll talk a little bit about tokens and private keys and keeping secrets and protecting those from GitHub and all that, and then also just more about building apps in Node that make requests and do things with those requests. Sound good? All right, thanks.
So I guess that's the question. Actually, I think this information that I still need to know, though, about these